Well, this particular video is going to focus on one way to represent the motion of an object. Now, we're dealing here with just one-dimensional motion. It can be a little confusing because when you look at this graph, you'll see some left and right and some up and down, and you'll want to picture things moving through the air in two dimensions. But this is a plot, and if you look at the axis, it's x versus t. X is our symbol that we use for position. Now, usually it's specifically used for horizontal position, so you can just imagine something on a track, like maybe a train on a track, or a marble on a little track, or in a physics lab we've got these little carts that we put on tracks. And that's all the motion we're indicating here. So there is no up or down motion, there is no side-to-side motion. So what are we seeing when we look at a position time graph? I've got one drawn here that shows four very typical kinds of motion that we would analyze, and I just wanted to show you how to interpret this. So I've got them lettered. Segment A here is what in math we would call a steady upward slope. So when you hear the word slope on a position time graph, you can replace it with the word velocity. So a steady positive slope means steady positive velocity. You know, cruise control, moving forward, is how you could think of that. So I'll write steady and positive velocity. So if we do the same thing for segment B, then what is that? Well, in math we'd say B has a slope of 0. That means it has a velocity of 0. So velocity of 0 is just a fancy way of saying we have no motion. And C and D are both segments of the graph where the slope is not constant, it's changing. And there's four different ways we can draw a non-constant or changing velocity. Now, I've shown you two here. So if you describe the slope of segment C, it's certainly getting less slopey. Starts out quite steep and ends up pretty flat here. So that means it's decreasing in speed. But what direction is it moving? Notice segment C is the first part. We're actually moving downward on the graph towards a more negative position. We actually start in the positive region and end in the negative region. So now trains don't generally move backwards, but this might be like a train moving backwards on the track. Or when you're doing a physics lab, if the cart starts moving the other direction. Often for horizontal motion, we think of backwards as leftwards, although it depends on your frame of reference. So it's not kind of hard and fast rule. So segment C, I would call backwards in direction and slowing. So there's really two features that you want to look at. What direction is it moving and what is happening to its motion as it moves. And then segment D, still backwards because we're heading down. Now we're in the negative region the entire time, but that's still getting more negative. And then the slope, you see, is getting steeper. When slope is getting steeper, that means it's getting faster. So I don't say speeding up. I avoid the terms up and down when I'm describing this. So I just use the phrase getting faster. So there's four different features that you can see. Now I'm going to show you a couple other ways that we can show changing motion on a position graph, but I want to redraw this first. So let me redraw it and then we'll pick it up again. Okay, so here you see four different shapes of curves that describe changing or accelerated motion on a position time graph. And these are the four ways that we can steadily accelerate. Now, these are actually all four different parts of parabolas. So the first two are actually what I had indicated on the previous part. So in part A, this is our moving backwards and getting slower because we're losing slope, we're losing speed. So this is backwards and slowing for part A. And part B, we'll write it down here, also backwards. Again, we're heading down on the graph, so that means it's going backwards, or in a negative direction, we often say to sound real smart and physicsy. But this is getting faster. Now, my English teacher would pick on me for lack of parallel structure here. I said slowing, but there is no word that makes sense here, fasting. So we could say getting slower and getting faster. That would be a little bit more parallel. But the English teachers aren't watching this, so we won't worry about that. So here are the other two, C and D. So if you want to try this yourself, maybe spoiler alert, I'm going to describe what these are, but maybe pause it here and see if you can figure out these. Certainly both of them are heading upwards on the graph. And so that means they're both moving forwards. But look at the slope. In part C, we start with low slope, pretty flat there, and it gets slopier, which means getting faster. So moving forwards, getting faster is C. And here in D, again, we're moving forwards, but we're getting slower or slowing down during that part. All right, I want to throw out one more term here that you're going to hear, and that is the word concavity. You'll hear this in calculus class. This will come up later when we start putting equations with this. So we describe anything with an upward kind of opening, like a bowl, for example, as being concave up. So if you look at these segments, segment A is concave up, and segment C is concave up. If we put those two together, they would form kind of the shape of a bowl, like that. And B and D, because they're shaped like this, opening downward, like an upside down bowl, those are called concave down. You'll sometimes also hear them called concave up as positive concavity, and concave down is negative concavity. So another way to kind of tie this in with some math terms. So that's pretty much everything you're going to see in terms of position time graphs. I'll stop it here. And any more detail, of course, find a little help from me when you get to class.